mismatch isn't really that big of a deal, or are you guys saying,
Actually,
because other things could come in and explain it?
We-
Or are you saying, no, nothing else can explain it, it's got to be the GIA?
So I don't think it's, so everybody was inducing the orange, a whole bunch of people were inducing this Orangeburg scarp basically for the change as you go from the mid-Atlantic down south into Florida. And if you actually look at the numbers, it just doesn't work. We can throw that one to the side. And so that's basically what we're starting to do now, is that now we feel like we have the spread in latitude with
What
the,
does that scarp do?
oh, it's uplifting, so you'd get changes in the
So
rate.
decoupling.
The records, basically. But when you actually look at how fast it's moved or how much it's moved over what time span, it just can't, it can only explain like 0.0, like 2 millimeters over, I mean, it just doesn't work. But these other things, a lot of the things we don't even know what their influence is, right? Like the thermosteric, how much is that? How much it's been modeled, but what are the uncertainties in the model? How do you, and so a lot of these things we just can't peel them apart yet.
So you're saying the GIA model does not include like the thermostat?
Right, yeah, no, I don't think so. No, he actually is starting to work on some really interesting stuff, though, to do with that.
There's a question back there.
Yeah.
Did you see forms that may have been transported by storms and things that were maybe out of place?
In the locations we're looking at, we're not like right on the open ocean, which is good, because then we'd probably have that problem, and then maybe have time gaps in terms of deposition, especially if you had a storm layer deposited, right? You could have gaps in deposition. But in these records, if you were to do the stratigraphy, I would basically be saying, oh God, maybe it changed, silt content changed about 10% there. It's basically, you would say, Juncus peat. It's not as pretty as the Juncus peat in the north, but that's just because of decomposition, right? And so, yeah.
In that curve that you developed for Florida, what's the chance of your big uncertainty is due to a mismatch in the dating?
In the dating?
Yeah.
Well, we have something like 50 dates. So what do you mean by dating?
Well, it's just the 2 points are so far apart in the time scale that I wonder
2
if you have
points.
an issue with the dating.
I think I'm not
When you showed your conclusion slide, maybe is that what you're talking about?
this?
No,
The lower part.
Oh, this. This is the same site. Yeah, that's even a bigger problem. So this is the same core. The green dots, this is the same core in one site. So we have either introduction of older material or we have an introduction of younger material. Yeah, so this is an acorn. I don't know, maybe it's just acorns are bad news, I'm not sure. Maybe a squirrel dug a hole, I have no idea.
So this suggests you have a bad date somewhere in that record.
Oh, there's definitely a bad date.
Okay.
These two, which leads me to think that it's, but this is harder to do, right?
What about
So-
the 2 blue dates?
The 2 blue ones?
Yeah, 3,000 years, so basal dates, right?
Yeah, this is a basal date and this is a basal date.
Can they be that far off?
Yeah.
Right, and so that's one of the other, right, exactly. But you can have introduction of, so we're coring with Russian core. And so I don't know if you've ever seen a Russian core, but it's a manual coring device and it has a blade that flips shut. So as you go down, it's open and then you close it. So ideally, you're not getting any infiltration as you come up. But you could get some on the way down, right? You could pull something from the top and bring it down with you. And the other thing we did notice about some of these environments is that these are, I'm sure you guys are very familiar with these environments as you live here, is that these nice sandy uplands, and there is potentially long-term storage of like bark or tree pieces in the upland that then get delivered in during storms. And so if you're dating bark or, you may get these just erroneous dates that you just can't trust.
Are you familiar with the Bermuda sea level curve?
Yes.
That's
What
kind of
one?
an ideal situation.
Bermuda?
Or the Barbados course, Fairbanks. They go back 18,000 years,
They-
where sea level was just racing like crazy.
They do.
Probably faster than your last,
Yeah, oh yeah, definitely.
The Bermuda
There's
sea
some
level curve is basal peaks on
coral,
Sloping bedrock, rock surface.
right?
Well, that to me is the ideal situation. You don't have to deal with.
Yeah, but where can I find a sloping bedrock surface?
Well, in West Florida.
Okay, I'm going to go to West Florida. I'm going to go there, and I'm going to bring you.
Do you believe,
No.
do you believe Updike's notion that Florida's uplift would be as a result of dissolution?
No, and we actually took the rate of dissolution, and it also can't explain a whole lot of this. It's just not. It's just not enough. Yes.
I've seen before the curves, the difference between the rates that you're getting, you and Dan and Roland are all getting from the salt marshes and the GIA models in the older part of the record. As we go down this area, you know, that distance from Churchill assumes that the convergence divergence in the mantle is uniform. I've tried to talk to Dick about this as well, is that, you know, you have land over this and this. Why should the flow patterns not be affected by the land distribution?
Yeah.
But he
These-
tried to explain it to him, and I didn't understand a word he said.
So in the paper he did with Simon, though, they did vary the thickness of the mantle, and they tested that. And the problem is, once you do that, it no longer matches in Maine.
I don't care about that.
Right. And it seems like there's more to learn about how heterogeneous and depth, how that's increasing or decreasing in terms of the pressure density, or basically the density. I mean, that's my, right, that's one of my things, yeah, is that root really impacting the mantle flow.
So there was one more question in the back of the room, and then maybe we could wrap up if you all want to talk in more detail. It sounds like it might be.
Sorry, so you used rhizomes for your secret community?
Yeah,
Had you considered using the forms themselves?
these are glutenated foraminifera.
Oh.
Yeah, so it's always been I really wanted to like take off the sand parts and try and date the little, you can't. And I figured somebody had probably tried that. It's one of those papers that you're not going to publish on you rarely publish the thing that doesn't work, right? But yeah, that'd be the only other kind of option, but it doesn't work. But yeah, so it's pretty much plants, and then we stay away from shells, and it's really good. I mean, you want something that you think is in situ, in place, right? So that's the best, the key. And plus, with the juncus, we can actually do a step further and actually measure where the rhizomes occupy, how far from the surface of the marsh, and actually put that into the insert, like take that out of the estimate.
All right, well, let's give Andrea another hand.